Hi, I'm Matt Schaefer, and welcome to DevOpsCasts, where we go over topics that live in that nebulous space between development and operations. Today, we'll start on Chef Server. As I mentioned last time, Chef Server is a larger, more scalable approach to using Chef. Since Chef Server is a somewhat large topic, we'll be covering it in two parts. Today, we'll do an overview of Chef Server, and I'll show you how to install it. Chef Server introduces another server to your architecture. This guy right here is your Chef Server, and it serves as a central repository for cookbooks, recipes, and other configuration information. Your application servers will now have a Chef client daemon running on them. Like last time, you develop your cookbooks on your local machine, but when we're finished, we use Knife to upload them to the Chef server. Since Chef server and Chef client processes are in constant contact, the application servers will then pick up the new cookbook and run through them in the same way we saw with Chef Solo. Chef server is especially useful if you have a large number of servers. With Chef Server, you don't have to wait for each machine to run the recipes before moving on to the next one, and transferring cookbooks to the app servers is done for you. It's also good if you have interdependent services. This is because Chef Server not only stores just cookbooks, but also serves as a system of record for configuration information. You can even search your infrastructure for nodes that have certain roles or configuration. For example, your application recipe could search for any available database node rather than hard-coding the database information in the recipe. Finally, it's useful in situations where you have multiple deployment engineers. With Chef Solo, you have to be careful to coordinate provisioning so that two people don't try to run cookbooks at the same time. Since Chef Server runs asynchronously, many people can upload cookbooks as they work on them, and the Chef client daemon will pick them up on the next run. We'll be running Chef Server on this VM I have handy. I've already installed my SSH keys and prepared the box using the Knife Solo command. I did this by running knife prepare and passing in the username and host of the VM. One more thing to note is that I've given this VM a bit more memory. Chef Server can be somewhat memory intensive as your cluster grows, so I recommend giving it at least 1 GB of memory for testing and about 2 to 4 for production work. There are a number of ways to install Chef Server, including options that use OS-specific packages. Today, we use the bootstrap method, which also uses Chef Solo to build the Chef Server. The first thing our server will need is a proper hostname. To set it on a running system, we use the hostname command and make a matching entry in etc hosts. Persisting this across reboot varies a bit between operating systems. In Ubuntu, we pass the hostname into the file called etc hostname. If you've got it set right, you should be able to run hostname-f and see a full hostname for your server. Now, since we're using Chef Solo, we'll need a node config. The run list will include the Chef Server RubyGems install recipe, and we'll set 2 attributes that tell the Chef Server its expected URL and that we want the web UI to be installed and available. And now we'll run Chef Solo using the config and pulling our cookbooks from S3. Note that this will take some time since it installs a lot of packages. You might have noticed that I'm using VMware Fusion today. The reason for this is that VirtualBox on macOS Lion seems to overconsume resources when running large apt-get installations like this. One way I found to work around this is to use the CPU throttle tool for macOS. If you run into similar issues, check the show notes for some information. Now that Chef is installed, we'll configure the root user's Knife utility. We'll use the local Knife tool to create certificates that we can use on our own laptop. To verify that it was configured correctly, we'll run Knife client list. The Ubuntu entry here tells us that it was configured correctly and can talk to the Chef server. To create a Knife client entry for myself, I'll use the Knife client create command. The options here tell Chef to create an admin account with default settings called mat, and to place the private auth certificate into temp mat.pem. Now back on my computer, I'll SCP that key over to my Chef folder and configure my Knife client. To configure our local client, we'll use Knife configure. The options here specify Matt as our Chef username. This matches the client we created back on the server. the path to the certificate we copied over, the URL to the Chef server, which defaults to port 4000, and finally defaults for the rest. To test that we have it configured correctly, we run knife client list as we did before. When running Chef server on VMs, it's easy to run into clock synchronization problems. If you encounter an authentication error that mentions synchronizing your clock, go back to the server and run ntp date against pool.ntp.org to fix it. This happens because the authentication mechanism in Chef only allows for 15 minutes of difference between the clocks on two systems. Now that the clocks are in sync, we should be able to run knife client list back on our laptop without any problems. One more thing I'll mention before we finish is that we also installed the Chef web UI. If we go to our server on port 4040, we'll get a nice web UI for all the functions we talked about here. The default password is in the sidebar. Just enter it here, give it a new password, and then you can browse around your Chef configuration in this way too. If we look at the Clients tab, we can see the Mat and Ubuntu clients that we've created. And that's it for today. In the next episode, we'll go over how to hook up the Chef client daemon to this Chef server and upload cookbooks so they get run on our app servers. Thanks for watching, and see you next time.